Here, one end of a metal wire is fixed to a ceiling and load 2 kg hangs from the other end. A similar wire is attached to the bottom of the load. Another load 1 kg hangs from the lower wire. This is lower wire. Here 1 kg is attached to it. Then the ratio of longitudinal strain of the upper wire to that of the lower wire. As the blocks are at rest, so net force acting on each block is 0. Here it is its weight, and let us assume it as tension in the wire T1. Here T1 and its weight, and as weight changes, tension changes. Here it is T1 minus mg0, which is T1 equal to mg. At the same time, the net force is T2 minus T1 plus 2g, which is 0, or other way saying this. Here this block whose mass is 1 kg, T1 will be g. There T2 will be g plus 2g, 3g. So these are the tension in the wires. Now he told another metal wire, a similar wire. Similar wire is attached, Young's modulus will be same. So here Young's modulus is stress by strain. Strain is change in length by torsional length. So in one case, what all same? Wire is same means Young's modulus is same, length also same, area of cross section also same. Then, so here F by delta L becomes constant. That means F by E becomes constant. F1 by E1 is F2 by E2. So the ratio of longitudinal strain is obviously proportional to extension. So here T1 by E1 is T2 by E2. So upper wire, here upper wire, tension in the upper wire is T2. So what he is asking is T2 by T1, which is E2 by E1. T2 here is 3G, T1 is G. So E2 is to E1 is 3 is to 1. The ratio becomes 3. So since lengths are same, strain is proportional to extension. Here a coil of 200 tons is rotated at half of a revolution per second and placed in a uniform magnetic field. Let us consider here uniform magnetic field into the plane, and coil is placed perpendicular to the magnetic field. So once it is placed perpendicular to the magnetic field, area vector of rectangular plane and magnetic field both are in the same direction, they are parallel. That means initially angle between area vector and magnetic field is 0. So now plane is rotated through some angle theta, then change in the flux will be BA cos theta. So it is rotated with an angular velocity omega, implies theta is omega t. So flux will be the EMF induced E is equal to magnitude point of view. So d phi by dt will be BA minus sine omega t into derivative of this minus BA omega sine omega t. It is for one turns. If coil contains n turns, then EMF induced will be NBA omega sine omega. He said maximum voltage. So E maximum will be when sine omega t is 1. Here it is NBA omega NBA. You're right. N he given it as 200 tons. Flux he given it as 0.01 Tesla. Area 0.2 omega. So it is rotated at half revolution per second. For full revolution, it takes 2 pi radians. For half revolution, pi radians. So omega will be uh, pi radians per second. That is, here I will write pi 0.01 and 2 zeros get cancelled, which is 0.4 pi, 4 pi by 10, which is 2 pi by 5, which implies beta equal to 5. And a particular hydrogen-like ion emits radiation of frequency when it makes transition from n equal to 2 to 1. So here electron of hydrogen is in second orbit. When it jumps from second orbit to first orbit by releasing energy. So energy in the nth orbit of energy of electron in nth orbit is this. For hydrogen atom, Z is 1. So in second orbit, energy associated with electron is this 2 square. So here it is, it releases energy and it enters into first orbit. So E here is 13.6 into this, 13.6 into 3 by 4. Similarly, when electron jumps from third orbit to first orbit, in that case, energy emitted will be 1 minus 1 by 9. So that is E1 by E2 will be 13.6 into 3 by 4, 13.6 into 8 by 19, 27 by 32. So H nu 1, here a given frequency related to when it jumps from second orbit to first orbit. What we have to find out is only nu 1, 27 by 32. So nu 1 will be 32 by 27 into nu. So 32 by 27, he given frequency as 3 into 10 power 15 Hz, which is 32 by 9 into 10 power 15. From this, value of X is 32. This will be the final answer. Here, uniformly charged wall. So, provides an electric field that is 2 into 10 power 4 Newton per Coulomb. Normally, a charged particle of mass 2 grams is suspended through a silk thread of length 20 centimeters and remains stayed at a distance of because of repulsion. So here it is. So because of repulsion, it stayed at 10 centimeter distance. Let us say this is theta. Here length of silk thread. So let us extend this. It is a charged particle. Here is electric field. Force acting towards right, QE. Tension is developed in the string. The tension component is balanced by its weight. Its horizontal component T sine theta. T sine theta here is QE. T cos theta is mg. From this tan theta here is QE by mg. Then charge on Q will be mg tan theta by E. Q here, mass is 2 grams in terms of kg. Theta here is sin theta is 10 by 20 half. Theta is 60 degrees, sorry, 30 degrees. Tan 30, 1 by root 3 by electric field 2 into 10 power 4 Newton Coulomb. So here it is, get cancelled. 1 by root 3 into 10 power minus 6 coulombs. 1 by root 3 microcoulombs, which implies x equal to 3. Here, in an ammeter, 5% of main current passes through a galvanometer. So, galvanometer is very sensitive, right? Sensitive to small currents. To measure large currents through galvanometer, shunt is connected parallel to it. So now galvanometer with shunt becomes, that is ammeter. Galvanometer has a resistance R. So resistance of ammeter will be, they are in parallel, GS by G plus S. So now he given all numerical values. What he said, an ammeter 5% of main current passes through the, say, let us say I current. 5% of the current is passing through this, and remaining 99 by current passes through the shunt. So potential difference across AB will be I by 20 into galvanometer resistance. Potential difference across the shunt into its, so resistance of galvanometer, let us say G. So these are parallel. Ig by 20 here is 99 by 20 into S. So here S will be G by 19. Now resistance of ammeter G by 19 by G plus G by 19 into 19 by 20G, which is G by 20 is the answer. So seems to be answer is not there. Let us convert it. Here it is one of the Bohr postulate. Angular momentum of an electron in the nth orbit is integral multiples of h by 2 pi. So first option is correct. So regarding nuclear forces, so nuclear forces are different from gravitational force as well as electrostatic force. So here nuclear forces different from gravitational or electrostatic force. So here he used the word central forces. Here gravitational force, if there are two masses kept at certain d, it's a gravitational force is always attractive. This mass pull this mass towards this, and this mass is pulled by second mass. So line of action of force is along line joining center. Such kind of forces are central forces. But here in case of nucleons which exist in the nucleus, the forces are not central forces, they are tensor forces. Here you have neutrons as well as protons. Because of spin motion, each one behaves like a dipole, and this is one nucleon which acts like a dipole. This is another nucleon, acts like another dipole, but line of action of force is not along. So here line of action of force will be somewhere, makes an angle theta. So these are not central forces. And another word he told, this is wrong. They are not central forces, but charge independent is correct. So in general, two positive charged bodies, they repel, but nucleus size is 10 power minus 15, which is 1 Fermi. So between neutron, neutron, so actually there won't be attraction, but within the small range, so they attract. Even between proton and proton also attraction, between neutron and proton also attraction, force between NP and force between PP and force between NN all will be same. And these are charge independent. It does not depend on the charge. So nuclear forces, they attract each other with equal forces. So charge independent is correct, central is not correct. So this statement is wrong. Why they are spin dependent? Suppose here they are spinning in the same direction, so attraction force will be more. If they are spinning in opposite direction, attraction force will be less. So nuclear forces obviously spin dependent. And here about the packing fraction definition, mass defect by mass number. If mass defect is positive, so that atom is unstable. If delta M is either less than or zero, atom is stable. That means the stability negative, it is stable. If mass here packing fraction is negative, it is stable. Packing fraction is positive, it is unstable. Hence, this statement also correct. Stability of nucleus is inversely proportional to value of packing fraction. So A correct, B correct, other than D, all are correct. Here a galvanometer G of 2 ohm resistance is connected in the given circuit. The ratio of charge stored in the capacitors. Here it is. Yeah, drawing the circuit, it is not so clear. So this one is 4 microfarads. So this is the capacitance of one capacitor. Another capacitor is 6 microfarad. So in between, galvanometer is connected. And here resistance is 4 ohms. Here this is 6 ohms. and galvanometer resistance is 2 ohms. So all these kind of problems we have to solve with respect to steady state. Steady state means charge do not pass through the capacitor. Right. So in steady state, so current it do not pass through the capacitor, it passes like this. Again, it is here is a capacitor, it cannot pass through this. Here current passes like this. So finally, so current passes along the path A, B, C, D. So now all these are in like series. Here it is 4 ohms. Again, here it is 2 ohms and then 6 ohms, 4 omega, 2 omega, and 6 omega are in series. That means effective resistance will be 12 ohms. And here battery EMF is 6 volts. So current through the circuit I is equal to 6 by 12, which is half ampere. Now question here is ratio of charge. Here steady state will not come immediately. Initially current charge passes through the capacitor. When potential difference across this is equal to the EMF, then current will not pass. So here potential difference across ABC, if you choose that path, is same as potential difference across is. So now if you take this capacitor, 4 microfarad capacitor, here it is 4 ohms, 2 ohms, 6 ohms. So I will take it as 6 ohms, here 4 microfarads. Let us potential difference across AC. Potential difference across half ampere current, 6 ohms resistance, 3 volts. So potential difference across AC is 3 volts. Then charge stored. Charge stored in capacitor is equal to, that is C1, 4 microfarads, that is 12 micro coulombs. So it as 1. Similarly, here between B and D, there is another capacitor named as C2, given value of it as 6 microfarads. So 2 ohms and 6 ohms are connected in series. So effective resistance is 8 ohms. So potential difference across 8 ohms will be I into 8, half into 8, 4 volts. So charge stored in capacitor C2 is equal to 4 into 6, that is 24 microcoulombs. Then what he's asking, ratio of charge stored in C1 and C2. So 1 divided by 2, C1 by C2, you get 12 by 24, half. In this 23rd question, first one, all zero here, all non-zero digits are significant, we know it, but 2 zeros between non-zero digits, all zeros that occur between any two non-zero digits are significant. So In 1001, number of significant digits is equal to 4. So here A maps to second option. And second point here, all zeros to the right of decimal point are significant. So 100.100 after decimal point, these are significant. So significant digits is 6. That is C maps to fourth one. And here all zeros that are right on the last non-zero digit right of decimal point and to the left of non-zero digit are not significant. So if you consider this 0.001, 0010, these two are not significant. Here significant digits are 5. So that means D maps to third one. And similar here, between non-zero digits 1 and 1, 0 is significant. So in this number of significant digits are 3. So first option C maps to fourth. Yes, first option is correct. In the meter bridge, when the resistance in the left gap is 2 ohms and unknown resistance in the right gap, the balance is found to be at 40 centimeters. So when Wheatstone bridge is balanced, P by Q is L by 100 minus L. It is a meter bridge, 1 meter length where it is 60 centimeters. It is P, it is Q. So unknown one is Q, it is 40 by 60. So here it is Q becomes 12 by 4, 3 ohms. So now we found the resistance in the unknown resistance, we got it. On shunting the resistance 2 ohms, the balancing length on shunting unknown. This is unknown resistance. Shunting means connecting parallel 2 ohm resistance. Now the balance length changes by. So now Q becomes 3 into 2 by 3 plus 2, that is 6 by 5 ohms. Again, the same formula, 2 by 6 by 5. So we don't know where it balances. Let us write L1 distance, which implies 10 by 6 is equal to L1 by 100 minus L1. From here, 500, which is 3L1, 8L1 is 500 L1, 250 by 4, 62.5. But he is not asking balance length changes. Changes means originally at 40, changes by what centimeter means 25.2, 22.5 centimeters towards right. Here a microwave of wavelength 2 centimeters falls normally on the slit of width. So it's a diffraction process. In the diffraction pattern, how fringes are formed. So here, diffraction, you know it. Obstacle is placed in the path of a light. It bends, and here in this is illuminated region. Here it is dark region. In between, you'll have a bright and dark bands like this. So this is the central bright fringe. So here is first dark fringe. This central bright fringe spreads up to some region, and so in diffraction process, first dark fringe is obtained at d sine theta is n lambda for first dark fringe n is 1. In case of interference, it is for bright fringe. In case of diffraction, it is for dark fringe. This is path difference. So d sine theta here is lambda. D is width of slit. So sine theta here is lambda he given. The microwave of wavelength 2 centimeters. Slit width is 4. That is theta is 30 degrees. But here, in fact, in interference pattern, all fringes are having same intensity. Here, intensity of each fringe is different. If you consider intensity graph of diffraction pattern, it will be central fringe, bright fringe, it spreads like this. So till where central bright fringe expands. So this one is so it spreads up to some region. This angle is theta. This is theta. So it spreads up to 2 theta, that is 2 into pi by 6. So pi by 3. 60 degrees. Here, to measure temperature coefficient of resistivity of a conductor, an electrical arrangement shown in the figure, the arm BC is made up of semiconductor. The experiment is being conducted at 25 degrees centigrade and resistance of the semiconductor arm is 3 milliohms. So here, finally, what he says, there is no deflection. Once there is no deflection, it forms a Wheatstone bridge. Then resistance of resistance of AD is equal to resistance of BC by resistance of DC. AB he given zero point 0.8 milliohms, both are in milliohms, they get cancelled out. Resistance of BC by this is 3 milliohms. Here also, this also we can write this resistance also in milliohms, so it will be 2.4 milliohms. But here, initially, when temperature is 25 degrees centigrade, that time resistance is uh, 3 milliohms. And arm BC, this one is cooled to which temperature? Cooled at the rate of 2 degrees centigrade. So this temperature is decreasing at the rate of 2 degrees centigrade per second. In 10 seconds, temperature decreases by 20 degrees. So originally 25, 20, right? 25 minus 20, that is present temperature is 5 degrees centigrade. So that is, so resistance of BC at 5 degrees centigrade is initially 3 mm. 3 mm into 1 plus alpha 5 minus 25. It is already 2.4, which we calculated in milliohms, which is equal to 1 plus alpha into minus 20. 1 minus 20 alpha is 0.8. 0.2 is 20 alpha. Alpha is 0.2 by 20. 0.1 by 10. 1 into 10 power minus 2 degree centigrade inverse. The next question, it's already similar kind of question we discussed in the same paper. Here, amount of charge is stored across the capacitor. All these problems are related to steady state. To calculate the charge stored in the capacitor, what we have to find out is potential difference across AB. It is enough to find potential difference across CD. So in steady state, no current flows through capacitor, so we can disconnect it. Now the circuit becomes Here it is 4 ohms. Again, we have 6 ohms. So effective resistance, the current through will be, that is 1 ampere current flows. And 1 ampere current flows, potential difference between AB. So VB minus, if you take apply Kirchhoff's second law, minus 4I plus 10 here is this. So VB minus VA is minus 6 volts. So VA minus VB will be plus 6 volts. Right, this is so which implies, in fact, here it is uh, here between CD 6 volts, between AB also 6 volts. Q becomes C into V, 10 into 6, that is 60 microcoulombs. Here a uniform rod AB of mass two kg, length he given 30 centimeters at rest on a smooth horizontal surface, an impulsive force of 0.2 Newton second acts on it. So impulsive force is, that is F into T, is 0.2 Newton seconds. That is F will be 0.2 by T. So let us, once you apply force, let us calculate the torque about this center of mass. It's a rod of length L, F into L by 2. Here perpendicular distance, force applied here, it is L by 2. I through center of mass. So center of mass it is ml square by 12. So you'll get cancelled. From here, F equal to ml omega by 60. So Ft here is ml omega by 6. Ft he given it as 0.2 newtons. M here is 2 kg. L is 30 by 100. So 0 get cancelled out. From here omega is 2 radians per second. So, so once time taken to turn through 90 degrees, here it is an angle. So theta becomes omega t. Here omega constant, angular velocity, angular acceleration 0, 2 into t. So that angular displacement is pi by 2, which is t. T becomes pi by 4, which is, from here you can say x value is 4. The frequency of electromagnetic waves is 60 million hertz, and it travels in z direction. The electric field and mutually perpendicular, and wavelength. The electromagnetic wave is nothing but a light wave. So maybe different wavelengths, velocity will be same in air. If medium changes, velocity changes. Here C equal to nu into lambda. Lambda here it is 3 into 10 power 8 by 60 into 10 power 7, 30, 60 million, right? 60 into 10 power 6, 300 by 60, it is 5 meters. Monochromatic light of frequency is produced by laser. So power is equal to rate of flow of energy. So if it is 1 photon, if there are n photons energy released, this is said per second. Take time as 1 second. Power becomes nhc by lambda in place of taking 1. Now power is already given 2 into 10 power minus 3. H value 6.63. I will take it as roughly 20 by 3 into 10 power minus 34. C is 3 into 10 power 8 by lambda. Lambda also, the given frequency, no need of this C by lambda. I can take it as a frequency here, which is given as 6 into 10 power 14. So 2 into 10 power minus 3, 40 into 10 power minus 20. And here is 2 by 40, 10 power 17. 200 by 40 into 5 into 10 power 15 roughly. So it will be a 5 is the answer.